Hi, welcome to a quick update on my solar generator, or as I prefer to call them, solar accumulator battery pack unit. Now, the last time I showed this, it was a 3S15P. Well, I didn't like the shape of the pack. It was a bit of a funny shape. I'd actually originally designed it to go into my first aid box solar accumulator. So as I've decided to change the packaging that it's going to be contained in, I thought it would be a good opportunity to actually change the package that this is made in. So I've added some extra cells. It's now a 3S16P, which is a whole extra cell over the 15P that I had before. It gains 2 amp hour or so extra, so it was worth doing. But more importantly, it's now a square brick shape, so it's a little bit easier to use. I've assembled these in as a 3S, so you've got a group here, group here, group here. I've used repacker.com to get the correct cells grouped together. I've tested all of the cells twice and then averaged the tested figures. It's surprising how much they vary. There's about, some of them don't vary at all, maybe a couple of milliamps, and some of them vary by about 50 milliamps, which is quite a lot considering they've been charged, discharged, and then recharged, and then discharged again. It's a surprising difference each time they're charged. I don't know if that's due to temperature or various conditions, I don't know, or even my Lito Color Lee 500, which is what I use. I use this thing here. That could have a slight variance every time it charges and discharges. So what I've done is I've done them twice, so this took some time. I've actually charged them all from my 12-volt solar system that I use in my workshop here. So they've been charged, discharged, recharged, and then discharged, and the measurements are measured twice. The numbers on here are an average, and then the averages I've put into repacker.com. Put that around the right way, and it's given me each pack is 34.754 amp hours, so it's okay. It's 375 watt hours and some change, 10.8 nominal voltage, but it's managed to sort them into groups of cells, which the little red dots are each time I've added them into the cell, just so that I can find each cell. But there's actually just a variance of 1 milliamp according to this, which is ridiculously accurate because my test procedure isn't that accurate. So that's done. I've grouped them together. I've been using the click, these Chinese kind of click together assembly things. They're quite good. They make nice, quick, easy packs. I've used a technique that I've seen a few people do, where you just drill some holes and run some zip ties through. This extra hole here is a mistake. We'll just ignore that, doesn't exist. It's not on the other side because I didn't make the mistake twice. So these are now grouped together as one brick. All I need to do now is link them up and then link across so that they produce a series pack. So there's going to be a link across there, positive to the pack could be there, negative to the pack could be there, and that's fairly simple. I'll just quickly go through what I'm going to add to these to make them work. I'll just quickly, I'm going to use a technique where you use 5 amp fuse wire linked to some heavy gauge copper to link the cells up. It's a quick and easy way, I think, of doing it. I don't have a spot welder, so I thought the easiest thing to do is just to use some heavy gauge copper. I've got plenty of thick copper wire, and then a 5 amp fuse wire just soldered across the top of the cells, and I was going to do the same on the back sides as well. And then I'll just join the groups of cells together with some heavy copper, so that I'm not losing too much power through heating thin wires. To go with this, in the box I'm using an ammo can. I'll be using these are going to be the solar inputs. Because I'm going to be using two solar MPPT chargers, each one has got a capacity of it's called an MPPT. It's not really MPPT. It holds the solar panel voltage at about 18 volts, which actually for my panels is about right. That's about the maximum power point. So each one of my little chargers can handle 3 amps. It's about a 50 watt panel, 50-60 watts. So what I'm going to do is I'm going to use these to the XT60s on the inputs. So the panels will have an XT60 plug, and then the socket will be on in the side of the ammo box where the batteries are stored. Those will feed the power into a couple of these things. This has actually got a heatsink on it, but I'm going to take this heatsink off and I'm going to mount 2 of these and the BMS, this is the BMS I'm using. These will be mounted onto a larger heatsink, so that, because they do get warm, they get surprisingly hot when it's handling 3 amps. And then what I'm going to do is the solar input will be on these, the blue yellows. Like I said, each one of those will go into its own XT60, so 60 watts of panel will go into this, and then this will be commoned up with its partner, if you like, and then we'll charge the cells via the BMS, which charges on the blue wire here, so they'll be linked together on the BMS. That's those. The control system will be completely handled by one of these little doohickeys. This uses a Hall effect pickup here. This uses one of these Hall effect things. It takes its power from here, then the ribbon goes into this, and then the battery positive cable will go through there, so this can monitor how much power the battery is actually outputting, or the load imposed on the cells. And I'm going to use this to control the entire system. So this has got various settings. You can have it disconnecting the power below a set voltage, and you can have it at various overcurrent, under voltage, all sorts of stuff. So this will be handling the whole thing. I'll be using it to switch a large relay. It'll be switching a 40 amp hour relay, and unless this is operational, I'm going to configure it so no power is fed out at all. So there's no way that this can be discharged unless the electronics are taking control. I figure that's probably the best way to go with this one, simply because I don't want the batteries destroyed. Although the BMS should stop them from being over discharged, I don't want any chance of them being shorted, or too much current being pulled out. So the electronics in this will be taking full care of what discharge parameters are allowed on these cells. These are cheap Chinese cells manufactured by a Chinese company called BAC. Information on them is limited. They were cheap, which is why I used them. But I have managed to find that they do have a maximum discharge capacity of 2C. So the nominal cell capacity, some of them peak up around 2.2 amps. That they are nominally 2,150 milliamps. That's their nominal capacity. Some of them are more, some of them are slightly less. So I'm going to apply a self-imposed discharge limit on this pack of 60 amp hours, which, being that it's rated at 34 amp hours, is under 2C. So they should be well within their capacity, even on the cells that are slightly low. See, some of them are around 2.6, 2163, 2167, 217, like that. So they're the lowest ones. There's a 2153 there. So at 2C that would be over 4 amp hours. So I'm not pulling pulling anywhere near their maximum 2C rating. They can charge at 2C as well, which I'm not going to do. My charger won't handle charging at 60 amp hours, so I think the maximum I can charge these at is about 0.2C, so about 6 amp hours. So that's still more than enough. It's fast enough, but it'll do the job. The other things I'm going to include with this, I'm going to run two 12 volt outputs. I've got two of these to go in it. One of them is going to be straight off the BMS, so it's going to be nominal battery voltage. The other one I'm going to be running through one of these DC-DC converters, and this one I've actually preset at 13.5 volts. So one of the outlets, although this is 12 volts, 120 watts, I think these are about 400 watts allegedly. One of them will be battery voltage and one of them will be regulated at 13.5 volts. That's just to make things that are fussy about battery voltage happy. I can't imagine there are many things around that need that, but that's what I'm going to do. I'm also going to have two of these, which are just USB outputs. These are quite good because these work down to about nearly 8 volts, so about 7.8 volts, something like that. So these will still output 5 volts, 2.1 amp hours, even when the batteries are right down to their minimum. So they're quite handy. They're quite a good little thing. I'm going to run two of those in set, so there'll be 4 USBs. And I've also got an inverter, a 500 watt 220 volt mains inverter, which although it won't run down at 9 volts, it runs down at 10.5 volts. So I can't fully discharge these cells using the inverter, which I'm actually quite pleased at because it draws around 50 amps and these are only rated at 60 amps. So I can't fully deplete these at high capacity using that inverter, which I think is a good thing. The downside is, of course, is I can't pull full capacity from the cells using the inverter. But, you know, it's a trade-off, and I'm happy to pull, say, 200 watt hours from it anyway. It's only really for, should I need an emergency, say, I want to run a TV for a couple of hours and that sort of stuff. So from that point of view, it's fine. So that's where I am at the minute. So once I've started building this, I've got to get the pack soldered up, and then I shall start assembling, and I shall do another post when it comes to do that. So thanks for watching. See you next time.